Welcome to the YouTube channel PCMB tutorials. I hope you all are fine. Today we are going to learn class 9th subject mathematics chapter logarithm part 1. This is a new chapter and we will learn many things starting from basic. The contents of this chapter are history of logarithms, exponents and logarithms, simple applications based on definition of algorithms, logarithms, conditions about n, a, and x, summary on conditions, applications based on conditions about n, a, and x, trivial features of logarithms, laws of logarithms, summary table on laws of logarithms, an important logarithmic identity, common logarithms, and questions based on them. History of logarithms. History of logarithms. Let us see what is the history of this topic. Napier first referred to his logarithms as an artificial number, but later he adopted the term logarithm. Logarithm translates as the number of ratios or the reckoning number. Napier denoted his logarithms by adding on a nap to the beginning of the log. All it meant was that this logarithm was calculated using this method, which was called Naperian logarithm. This terminology can be somewhat confusing, since natural logarithms are sometimes referred to as Naperian logarithms. Just Burgi, another mathematician, Just Burgi from Prague had been working independently on logarithms at the same time as Napier, but in a slightly different way. He realized his log tables in 1920. This took the form of comparison between a geometric series and a arithmetic series, and clearly show the operation and nature of logs. Henry Bridges, an English mathematician who at that time had been researching astronomy and its applications to navigation, immediately saw the potential for logarithms to ease astronomical and navigation calculations. As such, he turned his attention to developing the idea. During 1950 and 1960, Briggs traveled to Edinburgh to elaborate with Napier, where they modified Napier's logarithms, which at the time were to the base 1 by c and to the base 10. These were easier to work with and were more useful for Briggs' astronomical and navigational calculations. Logarithms to the base 10 are known as common logarithms or Briggsian logarithms in his honor. In 1924, Briggs published the Arithmetica Logarithmica, which included tables of logs from 1 to 20,000 and 90,000 to 100,000, means 1 lakh, to 14 decimal places, as well as information about the nature and construction of logs. We have seen in the laws of indices that the exponent of the form a raised to x is equal to k. where x is the power and a is the base. We can express the base a in terms of k. Like, let us understand in logarithm. Let us see exponents example. 2 raised to 4 is equal to 16. We know 2 raised to 4 is equal to 16, and this is our base. This is power, or we say it index. Power or index. And this 16 is the value of this power and index of the base. In logarithm, we can write this as log of 16 at the base 2 is equal to 4. Like this we can write this. Over here, this log of 16 means 16 is the number. This 2 is the base as it is, and 4 is called the logarithm. 4 is called the logarithm. And how to read this? So reading technique of this is log of 16 at the base 2 is equal to 4. Like one more variable example, if we'll take a raised to x is equal to y, we can write this as log this 16. The value is the number. Log of y at the base a. The base is same at the base a is equal to x. X is the power, which we call logarithm in log. Like this way, right? And we will read it as log of y at the base a is equal to x. Now the conditions in this are base should not be equal to 0. The whole conditions for this is, first, base should not be equal to 0. Second, base should be greater than 0. This base should not be equal to 0. This base should not be 0. And this base should be greater than 0. Also, base should not be 1. Base should not be 1. This base should not be 1. Number should be greater than 0. Number. Over here the number is this. Y is the number. Number should be greater than 0. And logarithm can be positive or negative or 0. Logarithm means this x. This x can be positive, negative and 0. I hope you have understood this part. In part 2, we will learn the rules of logarithms. Like there are rules of exponents. Likewise, we will learn 10 rules of logarithms in part 2. As this was the introduction part, we learned the basic things about logarithms, the history of logarithms and how to represent it. Let us meet in part 2 with a more high level concept, that is exponents. Like there is laws of exponents, there are laws of logarithm, and we will learn starting 10 laws. I hope you have understood this. Like this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. I hope you've understood this. Thank you for watching. Let us meet in part 2.